In this video, we're going to talk about the surface area of 3D shapes. Now, once again, hopefully you've already watched the other YouTube videos that I've posted, but I'm going to summarize quickly and then we'll dive into the homework. The basic idea of surface area of 3D shapes is, imagine we have a 3D shape and we're unfolding it and laying it out flat to fold something that's called a net. So if I have something like a cube, and I kind of cut it apart at the seams and I unfold it, I'm going to end up with something that looks like this. And then I find the area of each individual piece, I add it up, and that is the surface area of our cube. I also have a Mandarin to-go takeout box here. So this is an example of a rectangular prism. I'm just holding it together right now. I've already cut it so it will fold apart. So if we were asked to figure out what is the surface area of our rectangular prism here, of our box, what I can do and what I have done is I've cut apart the seams so I can unfold it. And how would I find the surface area of this? Well, I'd just find the surface area of each section. Section A, B, C, D, E, and F. And I'd add that all up, and that would give me the surface area of my 3D shape. So in each case, where do the formulas come from? What's the main idea? We're taking our shape and unfolding it to form a net. So that's what this is called. This is like our two-dimensional representation of our unfolded 3D shape. We're finding the area of each piece and adding it together, and that's the surface area. So the area of the surface of our shape. Sometimes we can just think about it though. So what I could do is, instead of unfolding it, I could just look and think, okay, I need to know the area of the top and the bottom, the front and the back, and the side and the other side. So that's the basic idea of surface area of 3D shapes. We're unfolding and then we're finding the area of our basic shapes that we already recognize and have worked with before. So let's work through a few practice questions here and get a feel for how do I calculate, how do I answer questions related to the surface area of 3D shapes. We're going to use our same process basically as before. Step 0, create a diagram if necessary. Next, identify the shape. Then we're going to label, find our formula, sub and solve, and write a conclusion if we need to. In our first case here, we are dealing with a cube. So let's take a look. Do we have a cube? Yes. Do we have surface area? Yes. Our formula for surface area of a cube is going to be 6s squared. What is my s? S represents side. So this here is my side. And in fact, every length in here is a side. We have the dashes here as well to tell us, hey, these are all the same size. So S represents every side, and S is going to be equal to 8 centimeters. So let's just plug it in. Surface area is 6 times S, which is 8 squared. Remember, the squared only applies to the 8. So this is going to be the same as 6 times 64, or just type it in your calculator. 6 times 8 to the power of 2 is 384. And remember, we're finding area, so my units are going to be centimeters squared. So remember, how many little square cubes would I need to put all around the whole surface in order to cover the entire shape? All right, next. C. What shape are we dealing with? We're dealing with a sphere. Let's check our sheet. So surface area, sphere. Here's our formula. Surface area equals 4 pi r squared. Let's add our labels. What variables do I need? 4 is a number. Pi is a number. I need to know my r. I'm not given r. I'm given diameter. I'm given all the way across is 12. But remember, r equals diameter over 2. So diameter is 12 divided by 2. So my r, my radius, is going to be 6 centimeters. So let's plug that in. Surface area is 4 times pi times 6 squared. So 4 times pi times 6 squared. It's going to be 452.4. Do you have any instructions about rounding? No. So we can round to the nearest number or nearest one decimal place if it doesn't tell us. So surface area is 452.4 centimeters. Remember, it's an area, so it's going to be squared. Let's double check our answer key really quickly, make sure I haven't made any mistakes. 1A, 384 centimeters squared looks good. 1C, 452 centimeters squared. Looks good. Next, we'll take a look at number 2. The diagram shows a greenhouse that is built in the shape of a half cylinder. How much will it cost to cover the roof if the material costs $3 per meter squared? And the shaded ends, so the ends here and here, will not be covered. So what information are we given? We're told that the cost is $3 per meter squared. That's going to be important in a couple minutes. And we're asked to find the surface area. So let's start by identifying our shape and finding the surface area. We're going to be dealing with a sphere. We're going to find the surface area. So surface area of a sphere is surface area, or sorry, not sphere, cylinder. Surface area of a cylinder is 2 pi r squared plus 2 pi r h. There's two things going on here, so let's talk about this formula first before we apply it. Imagine I have a full cylinder. There's two different pieces here. We have the top and the bottom, and then we have the part that's wrapped around the outside. So if I was to draw the net, if I wanted to see what this would look like, I could unfold it, and I'd have something like this. I'd have the top, I'd have the bottom, and I'd have the middle that wraps around. Which part of this is which part of this? Well, pi r squared is the area of a circle, and there's two of them. So this part of our formula represents the area of the end. So I'm just going to color code that. This part covers these surface areas. This part right here, 2 pi r h, because this is wrapped, because the sidewalls wrap around the circle. So how do I know how long this part is? Well, this part wraps around the circle once. That's our 2 pi r, and h is our length here. So that means that this part of the equation represents this part of our shape. Now, what do we know about our question? I know that we're only figuring out how much plastic we need to cover the roof of our cylinder. I don't care about the ends. That means that any part of my equation that deals with the ends of my cylinder can be ignored. So we just said this part deals with the ends, and this part deals with the sides, or side. So I can eliminate the part dealing with the ends. So we're going to not include this in our calculation. So surface area of our cylinder, side only, is 2 pi r h. Now let's also think about our specific question. What do we know about our shape? This is not a whole cylinder. So I'm going to calculate the surface area of the side, but I only need half of it. So surface area of a half cylinder, side only. We're going to take our equation, 2 pi r h, and divide by 2. The 2's are going to cancel out, so I can rewrite this as simply pi r h. Now that we've simplified, let's go ahead and solve. So we figured out what shape we're working with. We thought through the question carefully, and the formula we were given, we thought, do I need all parts of this? Let's customize our equation to fit our specific situation. Now I can sub in and solve. Let's go back a step actually and add our labels. Which part is my radius? Well, this is going to be the diameter of my circle. So if this is my diameter, my radius is going to be half, so it's going to be 10 meters. This part is my height. So imagine this was rotated. We had our circle on top and we extended down. So this part is my height. All right, let's plug in our values. Our surface area for this question we just said was pi r h. Pi is a number, it doesn't change. R we just said was 10. Height we just said was 80. Let's calculate. Pi times 10 times 80 is 2513, and we'll just round to the nearest whole number. That's fine. And what are our units? Meters, and its surface area. Area is squared, so it's going to be squared. We're not done our question yet, though. We've successfully found the surface area, just like we've done previously. But the question said, how much will it cost to cover the roof if the material is $3 per meter squared? So we need to take one extra step here, and I know that every meter squared costs $3. I know the total number of meters squared, so we're going to need to multiply those numbers. So our total cost equals our surface area times our price per meter squared. Let's just look at that with the units for a moment. Surface area is meters squared times dollars per meter squared. I have meters squared on the top and on the bottom. They're going to cancel out. I'm just left with numbers at the end, which makes sense because we're trying to find our total cost. So let's plug in our numbers. How many meters squared do we have? What was our surface area? 2513. What was our dollar for every 1 meter squared? 3. So $3 per 1 meter squared. You can write that if you want, or just write 3. That's fine. So 2513 times 3 gives me 7,539. So therefore, total cost is $7,539. Don't forget to include your units here, which are dollars. And let's double check our answer key and make sure that we got the right answer. So this was number 2. Yeah, I'm not working through these beforehand. You're watching me do this live, so I have not actually checked the answer yet. Question 2 says the total cost will be $7,540. So they just rounded slightly differently. That's okay. This is close enough. We have the right answer. So just to quickly overview once again, draw your diagram, figure out what shapes we're working with, check your formula sheet, and find the equation that we need. In this case, we had to make some changes to our equation because we didn't need the whole thing. And like I could have calculated it all and subtracted it out later, but if you can adjust your equation before you start plugging numbers in, that's a better way to do it. So we found surface area of a cylinder with the sides only. We only had half a cylinder, so we divided our equation by 2 and wrote the simplified form. We labeled and figured out which number was which. We did our sub and solve. We had the extra step to go from surface area to cost, so we multiplied by the cost per meter squared, which was $3. Got our final answer, summarized, including units. For our next question, let's take a look at 3A. And once again, this is all measured in centimeters. I just didn't have room to write it without smearing things. Determine the surface area for each composite 3D shape. So once again, just like when we've previously worked with composite shapes, we're going to break it down into its simpler shapes, carefully check the equation, and then go and work through. So I'm going to start by dividing this into 2 separate shapes. I'm going to cut it right here, and I'm going to have shape A, and I'm going to have shape B. One thing to be careful about, there is overlap. There's a place where these 2 shapes are merged together, and those surfaces are not included in the surface area. So we're going to need to deal with this part right here. So if I just look at shape B, it's a rectangular prism, and this side is on the outside, that's fine. This end of that rectangle is on the inside of the shape, so we're not going to include that. So keep that in mind as we work through this. Let's take a look at shape A. Surface area of shape A. So what kind of shape is shape A? Well, it's like a rectangle that's been extended. It's a rectangular prism. So let's take a look at our surface area for rectangular prism. 2LW plus 2LH plus 2WH. So let's work through that. 2LW plus 2LH plus 2WH. And I'm going to resketch the shape A by itself here for a moment as well. All right, I resketched my shape really quickly, and I included the shaded area to remind us to deal with it later. What do I know about this shape? I know the length is 10. I know the width is 8. And what's the height? It's not given directly, but in our composite shape, I know this had a height of 5 and this had a height of 5. So the height is going to be 10. And let's label length, width, and height. Let's plug in our values. So 2LW, 2 times length, which is 10, times the width, which is 8. So in other words, we're doing 10 times 8. We're finding the area of the top and the bottom. Plus 2 times LH, length and height. So we're finding the area of the side and the other side, and there's 2 sides, so that's where the 2 comes from. So length was 10, height was 10, plus 2 times the width and the height, and that's the width and height. That's going to be the area of the front and the back. So width is 8 and h is 10. All right, let's go and add these all up. 2 times 10 times 8 is 2 times 80 is 160, plus 2 times 10 times 10 is 200, plus 2 times 8 times 10 is 2 times 80 is 160, 32 plus 50. I don't want to make a mistake, so I'll just use my calculator. 520. My units were centimeters squared. So surface area of A is 520 centimeters squared, but don't forget this part here, the shaded area. So we just found the surface area of this whole rectangular prism. I need to subtract the shaded area now. So I'm just going to call that overlap. How big is that overlap? Well, let's figure it out. Do I know the length of this rectangle? Yes. Same as this length, it's 10. Do I know the height? Yes, it's the same as this. It's going to be 5. So 520 minus the area of the overlap, which we just said is a rectangle, 10 times 5. So 520 minus 50. So 470 centimeters squared. That is our actual surface area for A. All right, that's all right. Let's do part B. Hopefully I have enough room here. I might just have to write a little bit less detail. B is also a rectangular prism. So it's going to be the same formula. Surface area of B is 2LW plus 2LH plus 2WH. I'm going to redraw that rectangular prism really quick. Do I know the length? Yes, it's 12. Do I know the height? Yes, it's 5. Do I know the width across? Yes, it's going to be 10. So let's label. So length, height is 5, width is 10. Let's plug those numbers into our equation. Surface area B. I'm not going to have room to write all this, or it's going to be a little messy, so just do your best. 2 times length of 12 times width of 10 plus 2 times length of 12 and height of 5 plus 2 times width of 10 and height of 5. It's going to give us 2 times 120 plus 2 times 12 times 15 plus 2 times 50. So our total surface area is 700. And now we need to subtract that one end because of the overlap. 700. The area of the overlap is the same here as it was here. So it's 10 times 5. So the area of the overlap is 50. So the surface area of B is going to be 650 centimeters squared. But we're not quite done. What did the question say? It said find the surface area for each composite shape. I've only found the area of the individual shapes. So I found the total area, surface area of A, and the total surface area of B. I dealt with that overlap part that we don't include because it's not on the surface, so it's not part of the surface area. So let's add these up. Surface area of C is the surface area of A plus the surface area of B. 470 plus 650 gives us 1120 centimeters in its area, so it's squared. Let's double check our answer key. 3A, our answer should be 880 centimeters squared. All right, we're gonna have to go back and double check this. All right, I made a small mistake. Let's fix it together. So when I added all these up, I got 700. That was a mistake. It was supposed to be 460. So we don't need to make too many major changes here. It's just our last couple of I made a mistake in the last couple steps. So the process is still the same. I just made a calculation error. This is also why it's important to show your work. So you can go back and check mistakes. And if I'm marking your test, I can say, oh, you had the process right. You just made a calculation error. You still get most of the marks. So the surface area for all of shape B was 460 minus the area of the overlap. So 460 minus 50 is 410. So the surface area of B with the overlap subtracted is 410. So we're going to add our actual visible surface area for A, which is 470, plus our actual visible surface area for B, which is 410. And that'll give us a new final answer of 880 centimeters squared, which is the right answer from the booklet. This video is getting long enough, so I'm going to do one final question. Let's take a look at question 5. A sphere has a surface area of 350 centimeters squared. What is the diameter? All right, if you want to sketch a diagram for this, you can. I'm not going to bother. I know the shape, so let's go ahead and identify which equation we need. We're dealing with a sphere. We're dealing with the surface area. So our equation is surface area equals 4 pi r squared. And if you look at the sheet I've provided, I've actually rearranged the equation for you already. So if we need to find something different, if we want to solve for r instead of surface area, r equals surface area over 4 pi square root. All right, let's talk about this. I have my equation. I know the relationship between the surface area and the radius. I don't see diameter anywhere, but that's okay. We're going to rearrange this equation to solve for the radius. And remember, diameter is just 2 times the radius. So if I know the radius, I can easily find the diameter. So let's go through and see how I got this equation. I did give this to you on the formula sheet, but I also want you to know where it comes from. This is the equation in the original form given to tell us how to find surface area when we know the radius. This time we're trying to find the radius, so we're going to rearrange the equation to get r by itself. So let's take a look. Why is r not by itself right now? Let's do our SAMDEB. Is there anything to subtract or add? No. Is it being multiplied or divided? Yes. R squared is being multiplied by 4 pi. We can treat that as one number. So we're going to divide each side of the equation by 4 pi. So I'm going to get surface area divided by 4 pi equals r squared. And I have to deal with my exponent now. We're going to take the square root to undo the squared. And we're going to find out that the square root of the surface area divided by 4 pi is equal to the radius, and that's where we got our equation from here. So let's go ahead and use this equation and plug in our values. So I'm going to find my radius equals surface area, which is given in the question is 350, divided by 4 pi. There's no variables. We just need to do our calculation now. As always, you can do this in one step, but if you're getting confused or the answer's not working, you can do it one piece at a time. So I'm going to do 350 divided by bracket 4 pi, and then I'm going to find the square root of that answer. So this was like square root of 27.85. Finding the square root tells me that r is equal to 5.277. I'm going to round to 5.28, and then I need to find the diameter. Diameter is equal to 2 times the radius, so 2 times 5.28. So my diameter is equal to 5.28 times 2, 10.56. And in this worksheet, we usually round to the nearest tenth. So diameter is 10.6 centimeters. And was it a word problem? Do we need a concluding statement? No, that's okay. It is a word problem, but we've kind of stated directly diameter is 10.6 centimeters. Let's check our answers. This was number 5. Radius is 5.28 centimeters. Diameter, therefore, is 10.6 centimeters. All right, that looks good. Once again, any other questions you're stuck on here, please let me know. We're going to use the same techniques I've demonstrated here for the other questions. And if you have trouble, let me know and I can make another video or explain to you. Good luck with the practice questions. I hope they have either gone well for you or as you now try them on your own that they go well now. Good luck.